There are lots of other types of normal distributions that aren't standard. That just means the mean is not 0 or the standard deviation is not 1, or both of those. For these normal distributions, we usually use the variable x to represent the values instead of z. Remember that still the area under a normal curve represents a probability. Here's an example. Our basic problem is to find the probability that a randomly selected man weighs less than 140 pounds if we assume that the weights of men are normally distributed with a mean of 191 pounds and a standard deviation of 30 pounds. We're trying to find the probability that the weight, we're going to call that x, is less than 140. In probability notation, it would look like this. We'd have p of x less than 140. What we want to do is sketch our normal distribution and shade under the curve to the left of 140. When we draw in our normal distribution, we want to mark where the mean is because that's going to be right in the middle. The mean is going to be at 191. Oh, here's our mean at 191. We could go up or down by several standard deviations if we want to. This would be the numbers for going up or down by 1 standard deviation. And then we want to mark in there where our value that we're concerned with is. So 140 is a little bit more than 1 standard deviation below the mean. So it's about in there. And we're trying to find the probability that x is less than that, so we're going to shade from there to the left. Now we want to go to StatCrunch and find this probability. We're going to go to our normal calculator, put in 191 for the mean and 30 for the standard deviation. We're going to use less than or equal to for the inequality, and we're going to put in 140 for the value. When we do that and click on compute, it's going to give us this picture that matches the picture we had up here. And here's our probability in this box to the right of the equal sign. So the answer to our question is that the probability is 0.0446. When we're talking about probabilities, if the probability of something is less than 0.05, we usually say it's an unusual event. This would be an unusual event because our probability is less than 0.05. Let's do some more examples. In these, we're talking about IQ scores. These are normally distributed with a mean of 100 and a standard deviation of 15. For the first question, we're trying to find the percentage of the population that has IQ scores at or below 90. That's the same as finding the probability that x is less than or equal to 90. We're going to draw our picture. This time our mean is 100, so 100 goes in the middle. And we can put in some other values, going up or down by a certain number of standard deviations. One reason for doing that is to get an idea where our 90 would go, because we want to mark where 90 is. It's definitely less than the mean, so we want to put it to the left of the mean. And then we're shading from there to the left because this was x is less than or equal to 90, which points to the left. To do this in StatCrunch, we would put in 100 for the mean, 15 for the standard deviation, less than or equal to for the inequality, and we would put 90 in for the value. If we clicked on compute, we would get approximately 0.2525. Since in this one they were asking for a percentage, we could take this and convert it to a percent by multiplying by 100. We could round that to the nearest percent, and that would tell us that about 25% of the population has IQ scores at or below 90. Since we're looking at a less than or equal to situation, we could also interpret this as the 25th percentile for IQ scores. 25% of IQ scores are at or below 90. Now let's do part B. This is the probability that a randomly selected person has an IQ score above 90. This would be the same as finding the probability that x is greater than 90. We already know the probability that x is less than 90 because we found it in the last problem. And these two are complements of each other, so we really wouldn't have to do any more work except for subtracting our last answer from 1. If we take 1 minus our last answer, which was 0.2525, that gives us 0.7475. For the last example, we're trying to find the probability that the person has an IQ score between 85 and 115. So here's our picture. Our 85 and 115 both happen to be exactly 1 standard deviation away from our mean. We're shading between those two. To do this in StatCrunch, we would want to use the between window, put in our 85 and our 115, and we would get an answer of approximately 0.6827. That's our probability that a randomly selected person has an IQ score between these two values. With these kind of normal distributions, we can also work backwards. So if we know the area under the curve, or if we know the probability, we can work backwards to find the value of the variable. Again, in order to do this, we have to know the mean and the standard deviation for the normal distribution. In StatCrunch, we'll use the normal calculator going backwards for these problems. First of all, let's do some of these examples with z-scores. For number 1, we're trying to find a cutoff value for z-scores so that the area to the left of z is 0.81. As soon as it says z-scores, that means that your mean is 0 and your standard deviation is 1. Here's our normal distribution picture. We've got 0 in the middle because that's the mean. And this time, the area is 0.81. So we want to draw it so that the area to the left of this z-value is a little bit more than half. So we don't know exactly where to put this value, but we want our shaded region of our graph to be more than half of the graph. That means that this area in here should be equal to 0.81. Now we want to use the normal calculator backwards. We're going to put the 0.81 in the box that's to the right of the equals sign. Then when we click compute, it will give us the z-value, and this turns out to be 0.88. That's the value right here. For number 2, we're trying to find the cutoff value so the area to the right of z is 0.4677. We're drawing our picture again, and if we're finding the area to the right of z, that means that we're shading from this value to the right, and we want this area to be 0.4677. That's just a little bit less than half, and that means that this value is going to be a little bit to the right of 0. This is 0.4677 over here. This area on this side would be 0.5323 because they have to add up to 1. We could use our normal calculator backwards. We can either put in 0.4677 in the box to the right of the equal sign and use a greater than or equal to as our inequality, or if we wanted to, we could put this value into the box and use a less than or equal to for our inequality. It doesn't matter which way we do it, either way we should come out with the z-value being 0.08. Now let's go back to the elevator example. If we want to find what weight separates the lightest 10% of men from the heaviest 90%, this is another one where we would be going backwards. We want the cutoff value for the bottom 10%, or we could think of it as the cutoff value for the top 90%. This means that the area to the left of that value is 0.10, or we could think of it that the area to the right of the value is 0.90. Here's our picture. Our mean was 191, so that goes in the middle. Here are two values going up or down by 1 standard deviation. And what we want to shade, if we're thinking about the bottom 10%, that means that this area on the left is only 0.10, so it's going to be pretty small. It's definitely less than half. So this would be the 0.10 over here. We could also think of it that this area that's not shaded would be the 0.90. Whichever way we want to think about it, that's going to determine how we put our values into StatCrunch and which inequality we use. In this case, I used a less than or equal to, and I used the 0.10 for my area. So I was finding it with the way this picture is drawn, and this picture match. The value that it's giving me for x is 152.6. That means that the cutoff value for the lightest 10% of men is 152.6 pounds. We could also interpret this as the 10th percentile for men's weights. So 10% of men weigh less than or equal to 152.6 pounds.